Right, here we go with a lovely question about alpha particles and beta minus particles. Lovely. We want to know the number of protons, number of neutrons in a final nuclide for when thorium-232 does those decays that I've just mentioned. As ever, please press pause, try the question, and when you're ready to go, press play. Okay, so let's start off here by looking at some equations. We know that we've got thorium starting off, and it's going to become some element X, and that is going to have the nucleon number A, proton number Z, and then we've got these other ones alpha and beta. It's beta minus, so that's fine here. Okay. What we need to remember is that the numbers on the top must add up, and the numbers on the bottom must add up. So if we've got 90 on the bottom, then that has to, everything else on the bottom has to add up to make 90, 232 on the top. So let's take the top line. Well, we've got A plus 4 plus 0 is equal to 232. In other words, A is equal to the difference between 232 and 4, 228. Similarly, on the bottom, a bit more complicated. We've got 90 is going to be equal to Z plus 2 minus 1. In other words, our Z is going to be equal to 89. In other words, our alpha reduces it by 2, our beta increases it by 1. We're going to get 89. That's going to allow us to get rid of 2 of the answers. That's going to be A and B because they say 87. And the question is, how do we know the number of neutrons? The number of neutrons is not given here. This is the number of nucleons. We need to find the difference between those numbers. N equal 8xZ, which is going to be 228 minus 89, 139, which is why our answer here is C. Go on, you want that question in your exam. It's a nice one, bit of adding up, as well as a bit of understanding of conservation laws in these nuclear reactions.